In this chapter, we will be covering the chemistry of the water, rivers of life. In the previous chapter, we discussed the chemistry of the air and the atmosphere. We will also discuss the interface between these two sets of chemistry. Water is one of the most fascinating molecules that exists, and it has many unique properties that lead to a different type of characteristic that water can hold in the environment. This unique set of properties that water contains is what allows life to exist on Earth. To begin, let's look at the structure of water. Water is an oxygen bound to two hydrogen atoms, so 4 of the electrons in oxygen's octet are in bonds, and then it has 2 lone pairs of electrons on the oxygen. If you recall in our discussion of electronegativity, oxygen is more electronegative than hydrogen. This makes the oxygen-hydrogen bond very polar, and it allows for hydrogen attached to oxygen to do hydrogen bonding. The lone pair of electrons that are found on the oxygen also are able to do hydrogen bonding. The electrons are able to bind to a hydrogen in a different water molecule. This allows one water molecule to engage in 2 hydrogen bonds as donors and 2 hydrogen bonds as acceptors. These hydrogen bonds give water a unique hexagon structure when it forms liquids and crystals. The liquid density for water is 1 gram per milliliter, and the solid density for water is 0.92 grams per milliliters. Since the solid density is lower than the liquid density, solid water will float over liquid water. Without this, there would be a lot of issues with life living inside water bodies. If the ice melted as it cooled, then lakes and rivers would freeze from the bottom up and would be just one giant chunk of ice. If any life forms were unable to survive in the ice, they would perish. The heat of vaporization is the amount of energy that it takes to go from the water state into the gaseous state. Because water has an extremely high heat of vaporization for a liquid, it's able to obtain a large amount of heat from the atmosphere. Also, a large amount of heat will be required to convert water into its gas stage. These properties allow for all of the water on Earth to act as a huge heat sink and absorb the heat that's coming from the sun while not vaporizing. If you compare the boiling point of water to other molecules that have a similar molecular weight, the boiling point of water is going to be much higher. This is because of the hydrogen bonding. The amount of heat that is required to raise the temperature of 1 gram of material by 1 degree Celsius is called the specific heat. If we compare the specific heat of water to many other chemicals, such as aluminum or lead, we'll notice that the value is much higher. It takes a lot more energy to raise the temperature of water than it does, for example, iron or aluminum. You may notice that a lot of kitchenware is made out of the metals aluminum and iron. This is because of such a low specific heat for these materials. The majority of Earth's surface, 75% in fact, is covered with water. The majority of that water is seawater, nearly 98%. Only about 2% of Earth's water is frozen in the polar ice caps, and this includes both salt water and fresh water. It's important to note that that's an extremely high percentage of the water on Earth, which is seawater and has a high concentration of salt.